So welcome to the first tutorial um, uh, to Xilinx, where we will learn to make a module to implement full adder using two half adders. So as you can see, this is the circuit diagram of a full adder that is composed of two half adders. So each half adder has a sum and a carry, as you can see here. So we will implement this circuit on Xilinx. So let's start with that. So let's make a new project. Let's call it adder. So here you need to give the path. So in this case, I've already given the path and I don't need to change it. But if you want to change this path, just click here and you will be able to give a new directory to your project. Click next. So I guess I need to change the path. I have while clicking that I changed the path. So let's change it again. So yes. So next, let's click next. So now these are a few options that you need to be aware of. So if you are implementing your Verilog code on a certain FPGA, then you need to select appropriate options. And in this case, you select this, since we are only going to simulate this module. So just select this LSIM simulator and then click next and then finish it. So we have successfully made our project adder. So now we need to add some files in it. So let's add a new source. So let it be a Verilog module, because we want to make a Verilog. We want to write Verilog code for half adder and full adder. So select this Verilog module option, and let's. So since we are implementing this circuit, which is composed of two half adders. So first we will make a half adder, and then we will use the half adder module to make the full adder, right? So let's call it half adder, and now I've already so the path should be so here you should give the path of the project that you make. It is already given here, so you just click next and then click next and then finish it. So now you will get this window. So here you can write your code. So it is important first of all you need to specify the inputs and outputs. So I'll go back to this screen where I can see this half adder. So first I'm making this half adder. So it has two inputs and it has two outputs, right? So let's say I have this. So I have this output S and an output C, that is the carry out, and I have this input X and input Y, right? So I have two inputs X and Y and two outputs S and C, sum and carry, right? So now I need to specify which one of these are actually, because I know that these two are outputs and these two are inputs, but I need to tell this software that which one of these are inputs and which one of these are outputs. So use this keyword output to specify outputs, and these keywords input to specify inputs X, Y, right? So once you have uh, specified the input and outputs, so you need to go back to your circuit and see, do you need any wires? So I do not need any wires, any extra memory elements, because so this particular part of circuitry, if you look at it, has only two inputs and two outputs and no intermediate wires, right? So at this point in time I do not need any wires, so I'll just write the code. It has an XOR gate, so I'll use the XOR command and so this n1 is just the label. It specifies the instance of the first instance of or the n1's instance of the use of this XOR gate. So S comma C comma, so these are in fact, so the output of the XOR gate is S, and the inputs to XOR gates are X comma Y, right? And similarly, now you write the code for a carry, and it has a simple AND gate. So AND, so let label this instance of AND as N2, and so the output of this AND is C, that is carry, and it has two inputs X and Y, right? So this is the code for the half adder. If you want to confirm it, you go back, you see it has an XOR gate, two input XOR gate, and a two input AND gate. So now you need to simulate it, whether whether to check whether there are any errors. So click on the simulate. Now click on this uh, module, and then you will see this LSIM simulator, right? So now you need to click on this behavioral check. It will ask you to save the changes to the module, and so click yes. So now you see this yes sign. This green yes sign shows that there are no errors and it is perfectly fine. So now you need to write a test bench for this module to check whether it's working fine. So now again click on the new source, and here select Verilog test fixture, because now you are making a test bench and a test bench gives inputs, various types of inputs to check outputs, right? So now it is important that you name it as TB underscore and then the name of your module. So TB underscore name of your module. So your name of your module, if you remember, is half adder, right? So half underscore adder, and now click next. So this is important because here you will link your module half adder to the test bench. So now select this. If you have multiple files here, select this half adder. So now next, and then finish. So now you will see a window where you can write the test bench. So here in the test bench, the inputs are defined as registers, because so registers are memory elements which retain the previous inputs until the next input is changed. It retains the value until you change it, right? And so outputs are usually defined using wires, and and here you call your half adder module, and now within this initial begin module you specify the inputs, right? So in the first instance, let x and y be 0 0, and then in the second instance let them be 0 1. So this 100 hash 100 means, so this is the delay or the time for which this x and y will stay at 0 and 1, and uh, and then you make it 1 0, and then you make it 1 1, right? So effectively, if you look at it, this is truth table. So we have specified all possible inputs to this module, uh, and now we want to simulate it. So first click on the save button, right? And then click on this half adder. You will again see this LSIM simulator. You click on the behavioral check. Now once you have so you see this green symbol, now you can move to its to see its output.